4.4, the Pythagorean Theorem. In Unit 4, relationships with triangles. One of the most famous theorems in mathematics is the Pythagorean Theorem, named for the ancient Greek philosopher and mathematician Pythagoras. This theorem can be used to find information about the length of sides of right triangles. It's important to note that this theorem works only for right triangles. Remember in a right triangle that the side across from the right angle is the hypotenuse, and the hypotenuse will always be the longest side. The other two sides of the right triangle, the two sides that make up the right triangle, are called the legs of the right triangle. The Pythagorean theorem states that you can find the hypotenuse of the right triangle using all three sides. It states that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Let's watch this video to understand a little more deeply.
Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn about the Pythagorean Theorem, or Pythagoras' theorem as it's sometimes called. And you may be wondering, what's a theorem? And who in the world is Pythagoras? Well, in math, a theorem is simply a statement that has been proven to be true from other things that are either known or accepted to be true. And Pythagoras, well, he was this really smart dude who lived a long time ago in ancient Greece, and he proved the theorem. Well, historians aren't completely sure it was actually Pythagoras who proved it. It could have been one of his students or followers, but he usually gets credit for it. Anyway, the main thing that you need to know is that the Pythagorean theorem describes an important geometric relationship between the three sides of a right triangle. We're going to learn what that relationship is in just a minute. But first, there's several things that you'll need to know before you can truly understand the Pythagorean theorem or use it to solve problems. First of all, to understand the Pythagorean theorem, you need to know about angles and triangles. And you also need to know a little bit about exponents and square roots. So if those topics are new to you, be sure to watch our videos about them first. And second, even though the Pythagorean theorem is about geometry, you'll need to know some basic algebra to actually use it. Specifically, you'll need to know about variables and how to solve basic algebraic equations that involve exponents. We cover a lot of those topics in the first 5 videos of our Algebra Basics series. Okay, now that you've got all that background info covered, let's see what the Pythagorean theorem actually says. The theorem can be stated in several different ways, but the one we like best goes like this. For a right triangle with legs A and B and hypotenuse C, a squared plus b squared equals c squared. As you can see from this definition, the Pythagorean theorem doesn't apply to all triangles. It only applies to right triangles. As you know, right triangles always include one right angle that's usually marked with a square right angle symbol to help you identify it. And you need to know which angle is the right angle because it helps you identify an important side of the triangle called the hypotenuse. The hypotenuse is the longest side of a right triangle, and it's always the side that's opposite of the right angle. In other words, it's the side that doesn't touch or help form the right angle itself. In order to use the Pythagorean theorem, you need to be able to identify the hypotenuse because that's what the variable c stands for in the theorem. C is the length of the hypotenuse side. The other two sides of the triangle, the ones that do touch or form the right angle, are called its legs. Our Pythagorean theorem definition uses the variable names a and b to represent their lengths. Oh, and it doesn't matter which leg is called A and which leg is called B, as long as you keep track of which is which after you make your initial choice. Okay, now that we know the various parts of the Pythagorean theorem, let's think about what the relationship or equation a squared plus b squared equals c squared is really telling us. It's telling us that if we take the lengths of the two legs, sides A and B, and square them, which means multiplying them by themselves, a squared is a times a, b squared is b times b, and then if we add those two squared amounts together, they will equal the amount you'd get if you square the hypotenuse side, which would be c squared or c times c. That may sound a little confusing at first, so let's take a look at a special example of a right triangle that will help the Pythagorean theorem make a little more sense. This right triangle is called a 3, 4, 5 triangle because its sides have the relative lengths of 3, 4, and 5. And by relative lengths, I mean that the units of length don't really matter. The sides could be expressed in any units, inches, meters, miles, whatever. So the triangle could be of any size as long as its lengths would have the proportions 3, 4, and 5 relative to each other. Starting with the side that's 3 units long, which we'll call side A, what do we get if we square that side? Well, in arithmetic, squaring 3 means multiplying 3 times 3, which equals 9. And the geometric equivalent of squaring something actually results in a square shape. As you can see, this square contains 9 unit squares. So this red area represents the value a squared in the Pythagorean theorem. Next, let's look at the side that's 4 units long, which we'll call side B. Squaring 4 means multiplying 4 times 4, which is 16. Again, the geometric equivalent of that is a literal square that is 4 units on each side and covers a total area of 16 units. So this blue area represents b squared in the Pythagorean theorem. And finally, let's deal with the hypotenuse, or side C, which is the longest side. It's 5 units long. Squaring 5 means multiplying 5 times 5, which is 25. And the geometric equivalent is a 5 by 5 square that has an area of 25 units. So this green area represents c squared in the Pythagorean theorem. Now that you can see how the arithmetic parts of the Pythagorean theorem are related to the geometric parts of this right triangle, let's check to see if the Pythagorean theorem is really true, at least in this special case. On the arithmetic side, if you add up the amounts a squared and b squared, they really do equal c squared because 9 plus 16 equals 25. And with a little rearranging of our unit squares, you can see that the area of the squares formed by the 2 legs really does equal the area of the square formed by the hypotenuse. Wow, those ancient Greek dudes really were smart. Okay, but I know what some of you are thinking. That's cool and all, but why should I even care about the Pythagorean theorem? What's it good for? Well, as always, that's a good question. And the answer is, like many things in math, the Pythagorean theorem is a useful tool that can help you use what you do know to figure out what you don't know. Specifically, if you have a right triangle, but you only know how long 2 of its sides are, the Pythagorean theorem tells you how to figure out the length of the third unknown side. For example, imagine that you have a right triangle that's 2 centimeters long on this side and 3 centimeters long on this side, but we don't know how long the hypotenuse is. No problemo. The Pythagorean theorem tells us the relationship between all 3 sides of any right triangle, so we can figure it out. We know that a squared plus b squared equals c squared, so let's plug in what we do know into that equation and then solve it for what we don't know. Again, it doesn't matter which of the 2 legs is called a or b, so let's just label them like this and then substitute 2 for a and 3 for b in the Pythagorean theorem equation. That gives us an algebraic equation that has just one unknown, c. If we solve this equation for c, in other words, if we rearrange the equation so that c is all by itself on one side of the equal sign, then we'll know exactly what c is. We'll know the length of that side of the triangle. First, we need to simplify the left side of the equation since it contains the known numbers. And according to the order of operations, we need to simplify the exponents first. 2 squared is 4, and 3 squared is 9. Then we add those results, 4 plus 9 equals 13. And we have the equation 13 equals c squared, which is the same as c squared equals 13. Then, to get c all by itself, we need to do the inverse of what's being done to it. Since it's being squared, the inverse operation is the square root. So we need to take the square root of both sides. Taking the square root of c squared just gives us c, which is what we want on this side of the equation. But it gives us a little problem on the other side, because it's not easy to figure out what the square root of 13 is. It's not a perfect square, so it's going to be a decimal and probably an irrational number. But that's okay, because it's fine to just leave our answer as the square root of 13. Sure, you could use a calculator to get the decimal value if you really need one, but in math it's very common to just leave square roots alone unless they're easy to simplify. So the sides of this right triangle are 2 centimeters, 3 centimeters, and the square root of 13 centimeters. Let's try another example. For this right triangle, we know the length of the hypotenuse, 6 meters, and one of the legs, 4 meters. But the length of the other leg is unknown. So let's use the Pythagorean theorem to find that unknown length. As usual, we call the hypotenuse side C. Let's call the leg we know side A, and the leg we don't know side B. Then we can substitute the known values into the Pythagorean theorem and solve for the unknown value. Replacing the C with 6 and the A with 4 gives us the equation 4 squared plus B squared equals 6 squared, which we need to simplify and solve for B. First, let's simplify the exponents. 4 squared is 16, and 6 squared is 36. Now we need to isolate the B squared, and we can do that by subtracting 16 from both sides of the equation. On this side, the plus 16 and the minus 16 leave us with just B squared. And on the other side, we have 36 minus 16, which is 20. We can now solve the simplified equation for B by taking the square root of both sides, which gives us B equals the square root of 20. Again, it's fine to leave your answer as a square root like this. And some of you may know that the square root of 20 can be simplified to 2 times the square root of 5. We're not going to worry about simplifying roots in this video, but if you know how to do it, awesome. If you don't know, just leave the answer as the square root of 20 meters. Here's another interesting one. What if you have a unit square that's cut in half along a diagonal? Each side of the square is 1 unit long, but how far is it from one corner of the square to the other along the diagonal? Well, since the diagonal divides the square into 2 right triangles, we can use the Pythagorean theorem to tell us that unknown distance. We label the legs of the right triangle A and B and the hypotenuse C. And since we know that A and B are both 1, we can plug those values into the Pythagorean theorem equation, which gives us 1 squared plus 1 squared equals C squared. Now we solve for C. 1 squared is just 1, so the left side of this equation simplifies to 1 plus 1, which is just 2. That means C squared equals 2, and if we take the square root of both sides, we get C equals the square root of 2. So that's how far it is across the diagonal of the unit square. Okay, so that's how you use the Pythagorean theorem to find the length of an unknown side of a right triangle, which is its most common use. But there's another way that you can use the Pythagorean theorem that I want to mention. You can also use the Pythagorean theorem to test a triangle to see if it truly is a right triangle. In case you're not already sure. For example, what if someone shows you this triangle and asks, is this a right triangle? Well, it looks a lot like a right triangle, but it doesn't have a right angle symbol, and it would be kind of hard to tell if this angle is exactly 90 degrees just by looking at it. Maybe it's really close to 90, like 89.5 degrees. No worries. The Pythagorean theorem can tell us for sure if we know the lengths of all 3 sides of the triangle. If we know those lengths, A, B, and C, then we can just plug them into the Pythagorean theorem equation to see if it holds true. In this particular case, since the 2 shorter sides are each 3 centimeters and the longest side is 4 centimeters, we can plug those values in for A, B, and C and simplify to see what we get. 3 squared is 9, so on this side of the equation, we get 9 plus 9, which is 18. And on the other side, we have 4 squared, which is 16. Uh-oh, that doesn't look right. Our equation simplified to 18 equals 16, which is definitely not a true statement. That means that the 3 sides of this triangle do not work in the Pythagorean theorem. They don't fit the relationship a squared plus b squared equals c squared. And since the Pythagorean theorem tells us that all right triangles fit that relationship, this triangle must not be a right triangle. All right, so now you know what the Pythagorean theorem is, and you know how to use it. You can use it to find a missing side of any right triangle. And you can also use it to test a triangle to see if it qualifies as a right.
Okay, let's look at some examples using the Pythagorean theorem. This first example says to find the length of a hypotenuse of the right side. This example is for when you're looking for the longest side of a right triangle, or the side opposite the right angle. The first thing that we need to do is realize which side's the hypotenuse and which side are the 2 legs. So remember, the first thing you always want to do when working Pythagorean theorem is determine which side is C. And C will always be opposite the right angle. Then the other sides are going to be A and B. And again, it doesn't matter which one you choose to be A and which one you choose to be B. So I could call B 8 and A6, and I would get the same answer, so long as I make sure that my hypotenuse is C, and that's the side that's across from the right angle, or the longest side. So we have x squared, because C is labeled as x, plus 6 squared plus 8 squared, leg squared plus leg squared. Then we're going to square 6 and 8 to get 36 and 64, and then add 36 and 64 to get 100. Last, we're going to use the inverse of x squared, or of the squared piece, to get our final answer. We take the square root, and we get that x is equal to 10, telling us that the hypotenuse of this triangle is 10. Let's look at another example where we want to find a leg instead of the hypotenuse. This example says that a 16-foot ladder rests on the side of a house, and the base of the ladder is 4 feet away. And it wants to know approximately how high above the ground is the top of the ladder. So imagine you've got a ladder laying against a building, as you see in the diagram, and the ladder is 16 feet long and 4 feet away from the bottom of the building. And you want to know how far up is the top of the ladder. So that becomes your x. Remember, the first thing you're going to do is determine which side is the hypotenuse, which in this side is the 16. Okay, so that tells us that the 16, which is the length of the ladder, is going to equal the distance from the house squared plus the height of the ladder squared. That's your C squared equals A squared plus B squared. Next, let's plug in what we know. The length of the ladder is 16, the distance from the house is 4, and the height of the ladder is x from the diagram. Square each number. 16 squared is 256, and 4 squared is 16. Now we need to subtract 16 from each side. Every time we're solving for a leg of the triangle, we'll be subtracting instead of adding. Then take the square root of each side, and we get x is equal to the square root of 240. Finding a decimal approximation for that, since we're talking about real life and we don't usually talk about things being the square root of 240 feet high, we get a decimal and we get 15.491. Look at the answers. Your answers and your answer choices are either whole numbers or rounded to the nearest tenths place. If we give the answer 15.491 to the nearest foot, then 4 does not round 15, so that would be 15 feet. But 15 feet is not part of my answers, so I look at another way to write my answers. If I take 15.491, and I see here that there's one that's 15.5, does 15.491 round to 15.5? Well, I look at this 9. Here's my tenths place. I look at this 9. 9 does round the 4 to a 5, or 49 does round to 50, or 491 does round to 500 because that's where it's closest to. And so this rounds to 15.5 feet, telling us that our answer is D. The ladder is about 15.5 feet above the ground. This next example doesn't explicitly tell you to use the Pythagorean theorem. A lot of problems in geometry and in later on courses, you're going to be expected to recognize when you're supposed to use the Pythagorean theorem, which is anytime you're looking for an unknown side of a right triangle. This question says, find the area of the isosceles triangle with the side lengths 10 meters, 13 meters, and 13 meters. So the first thing you want to do is you want to sketch a picture of your isosceles triangle. Remember that an isosceles triangle has two equal sides and a base. So the two equal sides will be 13 and 13, and your base will be 10. In an isosceles triangle, the altitude to the base, the altitude is this piece right here, also known as the height, is also a perpendicular bisector. We know that perpendicular means it hits it at 90 degrees. And we know that bisector means it cuts it in half. So the altitude divides the triangle into two right triangles with these dimensions shown. If we want to find the area of a triangle, we know that we need to find 1/2 base times height. We know the base is going to be 10, but we're going to have to solve for the height. So let's look at this right triangle where we know one leg is 5, and we know the hypotenuse, the side across from the right triangle, is 13. So that tells me if we're using c squared equals a squared plus b squared, that 13 squared is going to be equal to 5 squared plus h squared. Square, and we get 169 is equal to 25 plus h squared. We're solving for a leg, so subtract 25 from each side and you get 144. Take the square root and you get h is equal to 12. But remember, we're not looking for the missing side as a final answer. We're looking for that missing side to find the area. So now we know that the height of this triangle is 12 meters. And we can find the area based on that. Again, area of a triangle is 1/2 base times height. The base is 10 and the height is 12. So all we have to do is plug it into the area formula and we get 60 meters squared, or 60 square meters, as the area of this triangle. We can also use the Pythagorean theorem to verify whether a triangle is a right triangle or not. There are other ways that we can verify if it's acute or obtuse, but let's specifically look at if the triangles are right triangles. So all we have to do is plug in to c squared equals a squared plus b squared and see if we get a true statement. Remember, the first thing you want to do is determine which side do you think the right angle is, and determine which side you think C is. In this particular problem, or in any problem, C is always going to be the longest side. So 3 times the square root of 34 is some decimal. And you can use your calculator to determine what that decimal is so you can compare the side lengths. If I take my calculator and I take the square root of 34, which is 5.8, and then multiply that times 3, I get that this side right here, is approximately 17.5. So you can see C will always be your longest side. That's an easy way to determine if you're plugging things in right. And remember, A and C don't matter. You can write them in either order. So in this case, we would take 3 times the square root of 34 squared and determine, is that equal to 9 squared plus 15 squared? Well, if I type this in my calculator, I end up with 306 is equal to 306. And because I got a true statement and the Pythagorean theorem works, that tells me that this triangle must be a right triangle. Let's try that again. Here is my C. I know that because it's my longest side. So the question becomes, is 26 squared equal to 22 squared plus 14 squared? Well, if I square those numbers, I get 676, 484, and 196. Adding together 484 and 196, I get 680. 676 is not equal to 680, and because the Pythagorean theorem fails, that means this triangle is not a right triangle. Now it's time for you to go practice. There's a quizzes link for you to practice coming up next. After you finish the quizzes and feel confident, begin the quiz. Thank you, and I hope this helped.